All right, today we're going to start our unit on solving quadratics. Notice here, there's not really any work to do here. It's just vocabulary words. The one vocabulary word you should already be familiar with is x-intercept. We know that all the x-intercepts are where the graph crosses the x-axis. All right. These other terms I put on here because they mean the exact same thing as x-intercepts. Solutions are when you substitute in your x value and your y value and you produce a true statement when you work it out algebraically. Zeros, you call zeros, there will be zeros because the function value will equal 0. The y value will equal 0 anywhere on the x-axis. And roots is simply another term that they use for x-intercepts. So anytime you're asked to find an x-intercept, a solution, a root, or a 0, you're going to follow these same rules. Remember, they're the same thing as x-intercepts. All right, so we want to do this by inspection. What are the solutions to the quadratic function below? And remember, solutions are x-intercepts. So if I look at my graph, I know my x-intercepts are at -1 and -5. So those would be my solutions. I also want to be able to do that algebraically because not all the time we're going to be given a graph. So I could write this function in intercept form by making two sets of parentheses. X, change the sign of -5, make it +5, times x, change the sign of -1, and make it +1. So what I want to do is I want to use the zero property, which tells us anything multiplied by 0 is 0, to show algebraically that the zeros of this function are the same as the solutions on the graph. So let's start with our first factor, x minus 5. So I would write down x plus 5 equals 0. And what I want to be able to do is I want to solve for x to find out what value of x would make this equal to 0. So to do that, I would subtract 5 to eliminate the 5 from the left side. Notice the 5's eliminate on the left side, so x equals 0 minus 5 is -5. So I know my first solution is -5, and that's what I showed here. Now to get the second one, I take my second factor, which we said was x plus 1, and I do the same thing. I set it equal to 0 to find out what value of x would produce 0 when substituted in. So to do that, I need to eliminate my 1 from the left side, so I'm going to take the opposite of +1 is -1, put that on both sides. My 1's eliminate on the left, so x equals 0 minus 1, which is -1, which matches what the graph told us. So we know that we did it correctly. Let's do it again. What are the solutions to the quadratic function below? If I look at the graph and find my x-intercepts, I know my x-intercepts are at 1 and 4, so those would be my solutions. All right? To show it algebraically, I would write it in intercept form, so I would say x, the opposite of 1 is -1, times x, and the opposite of 4 is -4. So to find use the zero property to show algebraically that the zeros of this function are the same as the solutions on the graph. So I need to take my first factor, which is x minus 1, and set it equal to 0. So in order to do it, I want to find the value of x that would make that factor equal to 0. So do the opposite of -1, +1, on both sides. Notice the -1 and +1 eliminate. So that leaves me x equals 0 plus 1 is 1. And that matches my first solution. Then I want to do the same thing with my second factor. My second factor is x minus 4. So I'm going to write down x minus 4 and find out where that's going to equal 0. So to do that, I need to eliminate the -4. So I'm going to add 4 because that's the opposite of -4. Notice it eliminates on the left. So that leaves me x equals 0 plus 4 is 4. So I've shown algebraically that my solutions are the same as the x-intercepts on the graph. One more example like this. I go to my graph to find my solutions. I get -3 and 2. I want to write it in intercept form, so I need my two parentheses. X, the opposite of -3 is +3, times x, the opposite of 2 is negative 2. So in order to use the 0 property, I want to set each factor equal to 0. So let's start with our first factor. X plus 3 equals 0. So I need to determine what value of x would make that equal to 0. So to do that, I'm going to subtract 3 from both sides. My 3's eliminate on the left. So x equals 0 minus 3 is negative 3. And that matches my first solution. Now we need to find the second solution. So we take our second factor, x minus 2, find out where that equals 0. And we need to eliminate the negative 2. So the opposite of negative 2 is positive 2. So we add 2 to both sides. Notice the 2's eliminate on the left. So x equals 0 plus 2, which is 2. And again, that matches the solution on my graph. Now let's look at a different type. Again, we want to know what are the solutions to the quadratic function below. So we check for our x-intercepts. In this case, we get negative 1 and 3. But this time it wants us to write the equation in vertex form. Now remember, vertex form, you have to locate the vertex. So my vertex is the minimum point. So we go up to 1. So that's going to give me x, the opposite of 1 is negative 1 squared. And then go over to my y coordinate, negative 4. Remember, you only change the sign of the number inside the parentheses. So if I want to show algebraically that the zeros of this function are the same as the solutions, what I'm going to do is I'm going to write my intercept form, x minus 1 squared minus 4, and find out where that equals 0. So again, I want to eliminate. So the first thing I'm going to eliminate is the negative 4. So I'm going to add 4 to both sides. That eliminates the 4 there. So that gives me x minus 1 squared. 0 plus 4 is 4. Now this is where it gets a little bit different because now I need to eliminate my square. And the opposite of squaring something is to take the square root. So I want to take the square root of both sides. So when I take the square root of the left side, that's going to eliminate my square. So I'm simply left with x minus 1 equals the square root of 4, which is 2. Now, if I square 2, I get 4. But also, if I square negative 2, I get 4. So I need to make that 2 positive 2 and negative 2 because it can equal each one of those. So in order to solve for x, again, I'm going to want to eliminate the minus 1. So I need to add 1 to both sides. That's going to eliminate my 1 on the left. So that's going to give me x equals positive 2 plus 1, which is equal to 3. And that was one of my solutions. But I've got to find my negative 1 solution. So in order to do that, I've got to work with when x can equal negative 2. So I'm going to rewrite it, and I'm going to say x can equal negative 2, again plus 1. And negative 2 plus 1 equals negative 1. And that's where I get my second solution. So make sure you do it with the positive 2 and the negative 2. Let's do another example. If I look at the graph to find my solutions, I see a solution's at negative 5, and the other solution is at negative 3. So I write those on top. Again, it wants me to write the equation in vertex form. So I've got to locate my vertex. My vertex, again, is my minimum point. So the x-coordinate's negative 4. So x, change the sign of negative 4, would be positive 4 squared. Locate my y-coordinate, which would be negative 1. Again, remember, do not change the sign of the y-coordinate, only the x-coordinate. So to show algebraically that the zeros are the same as the solutions, I'm going to set x plus 4 squared minus 1 equal to 0 and solve to find out if my solutions are the same. So the first thing I need to do is I need to add 1 to eliminate the 1. So that's going to leave me x plus 4 squared, and 0 plus 1 is 1. Remember, the x's eliminate there. Now, how do I get rid of my exponent? Well, the opposite of square is square root. So what I do to the left, I also do to the right. So when I do that, the exponent and the radical eliminate each other. So that leaves me x plus 4 equals 1. And remember, if I square 1, I get 1. But also if I square negative 1, I get 1. So it can equal positive 1 or negative 1. So I want to eliminate the 4 on the left side, so I need to subtract 4 from both sides. So the x's or 4's eliminate. That gives me x equals 1 minus 4, which is going to give me negative 3, which is one of my solutions. But I need to find my other solution, so that's where I've got to remember that I need to also work with the negative 1. So x also equals negative 1 minus 4, which equals negative 5. So there's my second solution. And here's why we need to be able to use both vertex form and intercept form. If I look at this graph here, I can only estimate where my intercepts are. My first intercept is somewhere between 0 and 1. So I could say it's possibly, let's say, 0.7. And my second solution is somewhere between 5 and 6. So I could say it's like something like 5.2. But remember, that's only an estimate. So that's why I want to be able to use the vertex form, because I know exactly what my vertex is. My vertex, again, is my minimum point. The x-coordinate of my vertex is 3, so I'm going to write x. The opposite of 3 is negative 3 squared. And my y-coordinate is 5, negative 5, minus 5. Remember, you only change the sign of the x-coordinate. So to show algebraically that the zeros are the same, I'm going to write x minus 3 squared minus 5 and see where it equals 0. So now what I need to do is I need to eliminate my minus 5. So to do that, I'm going to add 5 to both sides. My 5's eliminate on the left, so that gives me x minus 3 equals squared. 0 plus 5 is 5. Now, what I need to do is I need to get rid of my exponent. So to undo the exponent, I've got to do the opposite operation, which is square root. So take the square root of both sides. So that's going to leave me x minus 3 without the square root equals the square root of 5. Now the square root of 5, if you put in the calculator, it's going to be something like 2.2 if I round. Now remember, if I square that, I get square root of 5. But also if I square negative 2.2, I'm going to get 5. So what I need to do is I need to eliminate my negative 3. So I'm going to add 3 to both sides. And I need to find both of my solutions. So I know that x can equal 2.2 plus 3, which is the same thing as 5.2. And that is my first solution. To find my second solution, I need to do the same thing, but I need to work with negative 2.2. So x equals negative 2.2 plus 3, which if I put that in the calculator, I know that equals 0.8. So I was pretty close on my estimate, but I was a little bit off. Now what I want you to do is you have some on your online classroom to do. Use your notes to help you, and we'll talk more about it when I get back to class tomorrow.